Hello and welcome to this presentation on advances in non-energy products from coal. A study that looks at developments since our previous study in 2018, looking at the growing importance of coal as a feedstock. I will try and bring out the scale and diversity of the coal products industry and the most significant products. We'll consider why coal can be an attractive feedstock, what advantages there are, and consider some of the challenges facing this industry. Using coal can mean more emissions of waste, but surprisingly, coal products can help to lower emissions too. So why choose coal? Coal is a plentiful resource that is expected to remain available at relatively low cost. At the end of last year, it was priced around $56 a tonne, and more typically at $50 to $80 a tonne. In comparison, oil is closer to $450 a tonne, and LNG can be expensive too, and highly variable. For graphitic products, the high carbon content at 85% in thermal coal can be an advantage as we seek to simplify processes, and can be tailored, and these products can be tailored for our new industries in renewables and transport. Finally, when we consider the construction industry, where there is rising concern over resources, coal is one of the few alternatives that could be used to replace that or augment it. Coal can be transformed to be used across industry, but there are issues too. Looking at some of the opportunities for coal products, activated carbon is an example of already well-established products. Falling water quality issues mean rising demand for activated carbon, and we also need to purify chemicals and remove mercury from effluents. Carbon fibre has become the main fuselage material in aircraft, and strong lightweight materials have a role in EVs and wind farms, and also now for construction materials. Graphene is a revolutionary material, and there are also electrode materials, fertilizers, fuels, including hydrogen, that can be made from coal. Perhaps the most contentious is the extraction of rare earth elements from coal, in the news recently over controversial sources. The largest growth, though, is in chemicals, and we will look at that next, as the status has changed substantially since our last report. The headlines are remarkable for coal chemicals, especially for coal gasification. The intent is to add over 350 new plants within 5 years, and of these, over 150 are already under construction or commissioning. It's similar to the power station program we saw in the early 2010s in China, where a power unit was added every week. There are details on each chemical in the report, but it is gasification of coal that is growing fastest, making plastics and fibres using methanol to olefins technology. 10 million tonnes of metal production is being added each year. China is already dominant in tar chemicals, the traditional coal products we're most familiar with, and it now includes pitch fibre. But the scale of the coal gasification industry means that it is meaningful on the global scale now, driven by the desire of China to avoid oil and gas imports, something that is looking attractive to other countries. But there are issues. Coal chemicals are much more carbon intense than petrochemicals. You have to emit a lot of CO2 to get the right carbon-hydrogen ratio, and the plants are less efficient. The chemical sector already exceeds 1 billion tonnes of CO2. That's 300 million tonnes of coal that isn't bound up in products. There's global concern over plastic pollution, and coal chemicals may be affected by that as well as petrochemicals, possibly needing to adapt to different products, or if reuse and recycling is required, that may need to be done local to consumers in country. And finally, there's the risk of sustained low oil prices. Oil companies such as Shell and BP believe that oil will be priced around $50 to $60 per barrel in the long term, and that is close to the break-even price for the coal gasification industry. So turning now to rare earth elements, the demand for lanthanides is set to soar as we shift towards an electrical society. These are needed for electric motors, mobiles, renewables, and the source is controlled by one country that is seeking to maintain that position. Greenland has just announced it won't permit mining there, and some companies are already declaring they wish to prevent controversial deep-sea REE activity. And that takes us to coal-rich in REE, but still low compared to mineral ore content. We already have proof of concept of REE from enriched coals containing 300 to 400 ppm, so the issue is then economics. The latest pilot plant results in coal REE recovery have achieved 98% purity, better than had been hoped, and the latest version is assisted by X-ray sorting. REE tend to sit in the top of the coal seam, and then everything is mixed up, so a technique like that can really help in concentrating them. Other developments include acid mine drainage, concentrating membranes, surface treatments to improve access by reagents, and novel chemical techniques where chelates preferentially extract lanthanides and avoid use of chemicals, a possibly game-changing technology. As demand grows amid political uncertainty, coal REE could guarantee a supply, and some methods result in environmental improvements in old mine workings. Turning to carbon fibre, carbon fibre is already dominant in aerospace. Even safety critical items like engine housings are now made from fibre. It is expensive at over $50 a kilogram, but CO2 savings are really very substantial in aerospace. To open up new markets such as transport and construction, the cost must come down, and developers are seeking $5 a kilo for coal-based pitch fibre that would open up these markets. Asian companies are ahead of US and European car makers in adopting carbon fibre. The net CO2 savings are much more modest than for aircraft, and so fibre needs to offer more than just range reduction. In EVs, the battery compartment presents special issues, and as well as low weight strength, carbon fibre can allow better control over the temperature of the 1-ton battery. The issue is to achieve good product quality at a low price using coal. There's an emerging crisis in construction. The consumption of overconsumption of raw materials and sand, including sand, leading to higher costs. Cement is rising around 6% a year at the moment. Cement production leads the industry carbon emission table. We are building the equivalent of Paris each month to accommodate a growing urban population, and the recovery from the pandemic is likely to involve significant infrastructure investment. Coal is perhaps the only large-scale available resource we can draw on to replace or augment cement, and by tailoring carbon fibre it can be used to strengthen structures or insulate them, and some products can be made directly from coal. Switching to nanomaterials, and graphene is most relevant to coal. The properties of graphene, a planar form of carbon, a few atoms thick, are exceptional, and that is opening up new markets. About half is used to stabilize battery electrodes, but it is now offered this month as a new concrete mix, concrete, that may have the amount of concrete needed to achieve a strength in a building. Graphene adds a new type of bonding into the material, bridging microfractures. The price of graphene is falling and now can be used in commodities, and it's also beginning to replace carbon nanotubes as a preferential material. And key to us is that coal can be the source material. There are now 4 routes to graphene from coal: acid etching, molten salt, fast Joule heating, and electrochemical that can be used to make quantum dots to sheets of graphene. The NATL molten salt methods just won a major prize, and the product is used to make memoristas, a new form of rapid access permanent memory set to replace current devices in computers. In the fast Joule heating method, akin to a light bulb, coal is converted to graphene at short times and 3000 kelvins. If the power was maintained, the graphene would be converted to graphite. it's essentially quenched out. This apparatus is scaling up from the research 1 gram amount to a kilogram per day. Safety assessments of graphene and other nanomaterials have been very positive. Graphene looks more benign than certain carbon nanotubes, but Health Canada is currently investigating respiratory issues with a PPI graphene mask, and the industry is awaiting the results of that investigation. Turning now to potential uses for lignite. The UN has a number of initiatives to counter desertification and poor soil quality. With a rising population and falling food production, there's a crisis developing. There have been hundreds of field trials using oxidized lignite, and these showed benefits in the long term, in the 5 to 10 year range, and that product is now commercial. It's especially attractive to organic farmers as a replacement for natural humate. At the same time, there are great problems emerging in the use of chemical ammonia-based fertilizers such as urea. Ammonia emissions account for half of the fertilizer applied, and if lost in this way, ammonia is a severe respiratory irritant. Well, leaching into rivers, it can lead to anaerobic conditions from nitrates. This problem is not easily resolved, and not to use nitrogen potassium phosphate fertilizers would mean more encroachment of wild areas to maintain production. This problem may give the lignite option a boost as a real alternative, and could be in a large scale. So just to recap, on chemicals, the creation of a large-scale industry is remarkable, but there are issues. Should the move away from oil and gas gather pace, then coal processing might look expensive. The carbon intensity is much higher from coal and really needs CCS for credibility. It is now becoming meaningful and may defeat China's commitments to the Paris Agreement. Polymer and fibre products are in high demand, but also have serious waste issues, and the industry as a whole may have to radically change to address that. On carbon fibre, China has pushed ahead incorporating fibre into EVs and is set to gain an advantage due to that. The construction industry cannot maintain current building rates without an alternative building material, and carbon fibre can offer superior products, and low-cost coal is key to that. And my final slide, the development of 4 coal-based methods to make graphene is very encouraging, and can only accelerate the deployment of graphene where the price has been too high. It clearly won't be high tonnage, but the profitability of the carbon nanotube industry suggests a very profitable industry for graphene. The recognition of harmful emissions associated with chemical fertilizers and the increasing organic farmer sector may accelerate the adoption of lignite into the fertilizer market, an important large-scale option. And lastly, on lanthanides, there are great technical achievements in the extraction of RE from coal, and the determination of China to maintain its control over supply, and the fact that demand is set to soar, lends credibility to the economical extraction of RE from coal. And I've just listed a few of the other topics that I haven't been able to cover today at the bottom. So thank you for listening, and I'll be happy to take any questions on the presentation.